In this video, we're going to take a look at how we can use MATLAB to start analyzing graphs of functions. And mainly what we're going to do is we're going to use MATLAB to be able to identify the extrema of a function and the intervals of increase and decrease of a function. And essentially what we're going to do is we're just going to use MATLAB to find the derivative, plot the derivative, and then we're going to just print out some statements based on what we analyze from the graph. And you might be asking, well, why don't I just go ahead and plot the graph and analyze and find it that way? And certainly that's a valid statement. However, it never hurts to have a secondary method to be able to identify, some of those exact points if possible of increase, decrease, and extrema. So we're going to take a look at two examples. We're going to graph the derivative. We're going to estimate the extrema, and then we're going to estimate the intervals of increase and decrease. All right, so let's start by getting a couple sims variables. And let's define our function f as such. So f is going to be equal to 2 times x cubed minus 3 times x squared, and then minus 36 times x, and then plus 2. And we're just going to go ahead and plot this. We're going to find the derivative. So we're going to say deriv is going to be equal to diff of f comma with respect to x. Okay, so remember deriv is a new variable and diff f comma x is the command. And then we're just going to plot. Okay, so we're just going to do our easy plot, and we're going to plot the derivative, and we're going to plot it over the interval from -5 to +5. All right, so remember we have these brackets, we have -5, 5. All right, now before we can do anything, we have to actually graph the function or the derivative of the function, and then we can go ahead and find the extrema in the given interval as well as increase and decrease. So let's go ahead and run this. And it might take a moment. Or two. You might wish to fast forward a little bit until the new screen comes up. There we go. All right, so here's our derivative. And it looks like that maybe right about here is where we cross the x-axis, and that would indicate the extrema. Okay, so remember, the extrema of a function is found where the derivative or the graph of the derivative is going to cross the x-axis. Now, what might be helpful for us is to turn the grid on. So I'm going to do that. And I'm going to run this again, and hopefully it doesn't take as long as the previous execution. And what we can see right away is that right here at -2, or there's an extrema, and right here at +3, there's an extrema. All right, so what we're going to do is we're just going to make an fprintf statement. And we're going to say there are extrema at x equal -2 and x equals 3. And then we're going to \n. It's actually /. So this slash is the one that should be somewhere around the enter key, at least on my keyboard. All right, so make sure you use the /, not the \, the one that's usually coupled with the question mark. Now we can also determine the intervals of increase and decrease. And to determine the intervals of increase, we're just going to look at where the function is positive, or the derivative's graph is positive. And we notice that right here is 0. Anything below this horizontal line is where the function is going to be negative. All right, so it looks like from where x is -5 all the way to -2 at that extrema is one place where it's increasing. Okay, so we can do an fprintf. And we can say the function is increasing over -5, -2. And then notice it goes negative, but then it starts going positive again. In other words, the derivative's graph is positive from 3 until +5. Okay, so we're just going to do a union, just like we would if we were doing this by hand. And I just use the letter U, and I'm going to say 3, 5, and then /n. And then I can just copy and paste this statement. and I can figure out where the function is decreasing. And notice that the function is negative, or the graph of the derivative is negative from -2 until 3. All right, so we're just looking at the y value. Okay, so I'm going to say from -2, comma 3. Right, and we can just go ahead and execute this again. The graph's not going to change. The only thing that's going to come out that's different are going to be these three statements of increasing and decreasing. Okay. Now, the good news is that now that we have this code, we can do the same thing for the other function and just change a few of the parameters. Okay, so I'm just going to go ahead and delete this line, and I'm going to replace it with the function sine x minus 0.5. So remember, sine x is sine parenthesis x minus 0.5. And then we're going to divide that by cos x plus 1. And the other thing that I have to change is I have to change this interval right here, -3 to +3. And I'm just going to change that within the easy plot function. All right, so I'm going to go ahead and run this again. We're going to get a different graph, as we should expect. And this one's a little bit different in the fact that it doesn't necessarily cross at a nice, precise point, right? So what you can do is you could just go ahead and zoom in if you wanted to. And what I'm going to do is I'm just going to click at a spot, and I'm just going to zoom in, right? And it looks like right about maybe at 2.2. Okay, it's probably not exactly 2.2. We could probably zoom in a little bit more if we wanted to. And I'm just rolling the mouse for this, but it's probably a little bit more than 2.2, but we're just using the graph to estimate this. All right, so maybe like 2.22 or something like that if we really wanted to. But again, we're just using the graph to estimate. And so let's just use 2.2 as the extrema for this. Okay, so we're going to say that there is an extrema at 2.2. All right, and of course we could get the analytic value by doing this by hand, but we're just getting an estimate. Right? And then we can say that the function is positive from -3 all the way down to our 2.2. So in other words, it would be increasing over that interval, again, because the graph of the derivative is positive, and it looks like the graph of the derivative is going to be negative from 0, or I'm sorry, from 2.2 up until 3. If we were to zoom out a little bit, notice that the function does approach 3 and -3 at some point. It looks like it's asymptotic, but it is approaching there, and certainly it's increasing and decreasing along those intervals. All right, so we could just say from 2.2 until 3. All right, and so hopefully this is helpful for you all to being able to see how we can go through and determine some of the things that we were able to do analytically just by using MATLAB to be able to get some estimates for some of these increasing, decreasing, and the extrema of functions.